Tonight, we uncover the chilling realization that humanity's farthest emissary has not just reached the edge of space, but has inadvertently knocked on a door that was never meant to be opened. 15 billion miles from the warmth of our sun, a machine from the 1970s is screaming. For decades, we believed Voyager 1 was drifting through a silent, empty vacuum, a peaceful, lonely exit into the galactic ocean. But the data returning across the 22-hour temporal gulf tells a much darker story. It speaks of an impossible wall of fire burning at 90,000 degrees Fahrenheit, where there should be only absolute zero. It records a rhythmic, 3,000 Hz hum that sounds less like celestial static and more like a structured, architectural resonance. Most disturbing of all, in the winter of 2023, Voyager 1 stopped being a passive observer. It adjusted its physical orientation toward a patch of absolute nothingness without a single command from mission control, as if reacting to a physical nudge from something invisible, massive, and structured. We are now forced to ask the question NASA isn't ready to answer. Is Voyager 1 exploring the galaxy, or has it finally brushed against the physical scaffolding of a containment zone we were never supposed to see? To understand the nightmare currently unfolding at the edge of our solar system, we must first look at the vessel itself, a machine that has quite literally become a cosmic ghost ship. Launched in the late summer of 1977, Voyager 1 was never designed to survive this long or travel this far. It is a fragile relic of a bygone era, carrying dual redundant computer systems with a combined memory of less than 70 kilobytes. To put that in perspective, this machine is navigating the most hostile environment known to man with less computing power than the key fob you use to unlock your car. It records its scientific discoveries onto an old-fashioned 8-track magnetic tape drive, a piece of vintage technology that should have seized up decades ago. Yet, powered by the decaying heat of a plutonium-238 generator, this antiquated brain continues to pulse, a fading heartbeat in the infinite dark. For nearly half a century, Voyager 1 has been our lone witness. It raced past the giants Jupiter and Saturn, taking one last look back at Earth in 1990 to capture the famous pale blue dot, a mote of dust suspended in a sunbeam, before turning its back on its creators forever. Since then, it has been falling. It is hurtling through the vacuum at 38,000 miles per hour, heading toward a boundary that, for generations, existed only in the theoretical models of astrophysicists. We imagined this boundary, the Heliopause, as a clean, definitive line, the place where the sun's protective influence ends and the interstellar medium begins. We viewed it as a peaceful transition from our solar neighborhood into the grander galactic sea. We were wrong. The isolation of this machine is total. Because of the staggering distance, any signal Voyager 1 sends takes over 22 hours to reach the massive, deep space antennas on Earth. When NASA engineers send a command to fix a glitch, they must wait nearly 2 full days just to hear if the probe survived the instruction. This temporal delay creates an eerie, detached dialogue between humanity and its most distant artifact. It is like sending letters across an eternal ocean, never knowing if the recipient is still the same entity that left the shore. And as Voyager 1 approached the absolute limit of the sun's reach, that entity began to change. In the summer of 2012, the scientific community celebrated. Voyager 1's instruments recorded a sudden, violent drop in solar particles and a massive spike in galactic cosmic rays. The champagne was popped, the press releases were drafted. Humanity had officially become an interstellar species. But behind the closed doors of the Jet Propulsion Laboratory, a creeping sense of unease was beginning to take root. The transition wasn't a clean exit. Instead, the probe had slammed into a region that defied every law of physics we had programmed it to understand. The first indication that something was deeply wrong came from the magnetometer. According to every model we possessed, the moment Voyager 1 left the sun's influence, the magnetic field should have snapped. It should have shifted aggressively to align with the magnetic orientation of the galaxy. It is the ultimate signature of leaving home, the cosmic equivalent of your compass needle, spinning wildly as you cross into an alien territory. But it didn't happen. As Voyager 1 plunged into the interstellar void, the magnetic field remained stubbornly, impossibly parallel to the field back inside our solar system. It was too perfect. It was as if the probe hadn't actually left the sun's domain, but had instead been wrapped in an invisible shroud. This is where the official narrative begins to thin and the deep lore of the edge takes over. Some analysts began to whisper that this magnetic smoothness wasn't a fluke of nature, but evidence of a draping effect, as if our entire solar system is moving through a dense, heavy medium that is catching the galaxy's magnetic lines and wrapping them tightly around us like a silk sheet. But how can a vacuum wrap around a sphere? This implies that the space Voyager is currently swimming through isn't empty at all. It is getting thicker. As the probe pushed deeper into this transition zone, the sensors registered a 300% increase in plasma density. Imagine an ocean liner sailing out to sea, only to find that the further it gets from the coast, the heavier and more viscous the water becomes. The vacuum was thickening into a traffic jam of particles. Mainstream science calls this a stagnation region, a natural piling up of solar wind against the interstellar wind. But fringe theorists and deep lore analysts look at the stability of the 3,000 Hz hum that Voyager has been recording for years and see something else. Structure. A cloud of smoke doesn't hum when you pluck it. Only something with tension, like a guitar string, can hold a resonance for 1 billion miles. The terrifying implication is that Voyager 1 hasn't just found a boundary, it has brushed against the invisible skeleton of our sector of the galaxy. The data hints that we are not drifting in a formless void, but are actively embedded in a larger, highly organized cosmic framework, a dark matter filament or a magnetic containment zone that acts as a physical cage. This transforms the Heliopause from a protective bubble into a prison wall. The psychological weight of this realization cannot be overstated. We sent Voyager 1 out as an explorer, but it has returned as a victim of its own discovery. The machine is now navigating a no-man's land where the rules of the 1970s no longer apply. It is a ghost ship sailing through a ghost fire, recording a persistent, rhythmic pulse that seems to respond to the sun's own rhythm, as if the boundary itself is breathing. And then there was the nudge. In late 2023, Voyager 1 did the impossible. Without a single command from Earth and with no thrusters firing, the spacecraft physically rotated. Its high-gain antenna, which must remain locked on the pale blue dot to maintain communication, shifted its gaze toward a null point in space, a patch of absolute blackness where gravitational forces perfectly cancel each other out. This wasn't a software bit flip, it was a torque event, a measurable physical change in orientation. It was as if something out there reached into the dark, understood the design of our machine, and gently steered it. This is the chapter of the mission NASA rarely discusses in public. It is the moment the conversation shifted from what is Voyager detecting to what is detecting Voyager. We are no longer looking into the abyss. Something in the abyss has reached out to adjust our perspective. As we move forward into the heart of this mystery, we must confront the reality that our 1970s pioneer is currently witnessing the dismantling of our understanding of the universe, one garbled 22-hour whisper at a time. But the ghost ship is no longer alone, and the "Are you ready to listen?" message decoded by quantum processors may be the final warning we ever receive. Tonight, we uncover the chilling realization that humanity's farthest emissary has not just reached the edge of space, but has inadvertently knocked on a door that was never meant to be opened. 15 billion miles from the warmth of our sun, a machine from the 1970s is screaming. For decades, we believed Voyager 1 was drifting through a silent, empty vacuum, a peaceful, lonely exit into the galactic ocean. But the data returning across the 22-hour temporal gulf tells a much darker story. It speaks of an impossible wall of fire burning at 90,000 degrees Fahrenheit, where there should be only absolute zero. It records a rhythmic 3,000 Hz hum that sounds less like celestial static and more like a structured architectural resonance. Most disturbing of all, in the winter of 2023, Voyager 1 stopped being a passive observer. It adjusted its physical orientation toward a patch of absolute nothingness without a single command from mission control, as if reacting to a physical nudge from something invisible, massive, and structured. We are now forced to ask the question NASA isn't ready to answer. Is Voyager 1 exploring the galaxy, or has it finally brushed against the physical scaffolding of a containment zone we were never supposed to see? To understand the nightmare currently unfolding at the edge of our solar system, we must first look at the vessel itself, a machine that has quite literally become a cosmic ghost ship. Launched in the late summer of 1977, Voyager 1 was never designed to survive this long or travel this far. It is a fragile relic of a bygone era, carrying dual redundant computer systems with a combined memory of less than 70 kilobytes. To put that in perspective, this machine is navigating the most hostile environment known to man with less computing power than the key fob you use to unlock your car. It records its scientific discoveries onto an old-fashioned 8-track magnetic tape drive, a piece of vintage technology that should have seized up decades ago. Yet powered by the decaying heat of a plutonium-238 generator, this antiquated brain continues to pulse, a fading heartbeat in the infinite dark. For nearly half a century, Voyager 1 has been our lone witness. It raced past the giants Jupiter and Saturn, taking one last look back at Earth in 1990 to capture the famous pale blue dot, a mote of dust suspended in a sunbeam, before turning its back on its creators forever. Since then it has been falling. It is hurtling through the vacuum at 38,000 miles per hour, heading toward a boundary that, for generations, existed only in the theoretical models of astrophysicists. We imagined this boundary, the Heliopause, as a clean, definitive line, the place where the sun's protective influence ends and the interstellar medium begins. We viewed it as a peaceful transition from our solar neighborhood into the grander galactic sea. We were wrong. The isolation of this machine is total. Because of the staggering distance, any signal Voyager 1 sends takes over 22 hours to reach the massive deep space antennas on Earth. When NASA engineers send a command to fix a glitch, they must wait nearly 2 full days just to hear if the probe survived the instruction. This temporal delay creates an eerie, detached dialogue between humanity and its most distant artifact. It is like sending letters across an eternal ocean, never knowing if the recipient is still the same entity that left the shore. And as Voyager 1 approached the absolute limit of the sun's reach, that entity began to change. In the summer of 2012, the scientific community celebrated. Voyager 1's instruments recorded a sudden, violent drop in solar particles and a massive spike in galactic cosmic rays. The champagne was popped, the press releases were drafted. Humanity had officially become an interstellar species. But behind the closed doors of the Jet Propulsion Laboratory, a creeping sense of unease was beginning to take root. The transition wasn't a clean exit. Instead, the probe had slammed into a region that defied every law of physics we had programmed it to understand. The first indication that something was deeply wrong came from the magnetometer. According to every model we possessed, the moment Voyager 1 left the sun's influence, the magnetic field should have snapped. It should have shifted aggressively to align with the magnetic orientation of the galaxy. It is the ultimate signature of leaving home, the cosmic equivalent of your compass needle spinning wildly as you cross into an alien territory. But it didn't happen. As Voyager 1 plunged into the interstellar void, the magnetic field remained stubbornly, impossibly parallel to the field back inside our solar system. It was too perfect. It was as if the probe hadn't actually left the sun's domain, but had instead been wrapped in an invisible shroud. This is where the official narrative begins to thin and the deep lore of the edge takes over. Some analysts began to whisper that this magnetic smoothness wasn't a fluke of nature, but evidence of a draping effect, as if our entire solar system is moving through a dense, heavy medium that is catching the galaxy's magnetic lines and wrapping them tightly around us like a silk sheet. But how can a vacuum wrap around a sphere? This implies that the space Voyager is currently swimming through isn't empty at all, it is getting thicker. As the probe pushed deeper into this transition zone, the sensors registered a 300% increase in plasma density. Imagine an ocean liner sailing out to sea, only to find that the further it gets from the coast, the heavier and more viscous the water becomes. The vacuum was thickening into a traffic jam of particles. Mainstream science calls this a stagnation region, a natural piling up of solar wind against the interstellar wind. But fringe theorists and deep law analysts look at the stability of the 3000 Hz hum that Voyager has been recording for years and see something else: structure. A cloud of smoke doesn't hum when you pluck it. Only something with tension, like a guitar string, can hold a resonance for 1 billion miles. The terrifying implication is that Voyager 1 hasn't just found a boundary, it has brushed against the invisible skeleton of our sector of the galaxy. The data hints that we are not drifting in a formless void, but are actively embedded in a larger, highly organized cosmic framework, a dark matter filament or a magnetic containment zone that acts as a physical cage. This transforms the heliopause from a protective bubble into a prison wall. The psychological weight of this realization cannot be overstated. We sent Voyager 1 out as an explorer, but it has returned as a victim of its own discovery. The machine is now navigating a no-man's land, where the rules of the 1970s no longer apply. It is a ghost ship sailing through a ghost fire, recording a persistent, rhythmic pulse that seems to respond to the sun's own rhythm, as if the boundary itself is breathing. And then there was the nudge. In late 2023, Voyager 1 did the impossible. Without a single command from Earth and with no thrusters firing, the spacecraft physically rotated. Its high-gain antenna, which must remain locked on the pale blue dot to maintain communication, shifted its gaze toward a null point in space, a patch of absolute blackness where gravitational forces perfectly cancel each other out. This wasn't a software bit flip, it was a torque event, a measurable physical change in orientation. It was as if something out there reached into the dark, understood the design of our machine, and gently steered it. This is the chapter of the mission NASA rarely discusses in public. It is the moment the conversation shifted from what is Voyager detecting to what is detecting Voyager. We are no longer looking into the abyss. Something in the abyss has reached out to adjust our perspective. As we move forward into the heart of this mystery, we must confront the reality that our 1970s pioneer is currently witnessing the dismantling of our understanding of the universe, one garbled, 22-hour whisper at a time. The ghost ship is no longer alone, and the "Are you ready to listen?" message decoded by quantum processors may be the final warning we ever receive. As Voyager 1 continued its lonely, one-way journey, pushing millions of miles deeper into the uncharted abyss, the engineers back on Earth were prepared for one specific enemy: the cold. For decades, the primary threat to the mission was the unrelenting, absolute deep freeze of the outer solar system, a barren wasteland where the temperature plummets toward absolute zero and all molecular motion simply stops. NASA had meticulously engineered the probe to survive this eternal winter, equipping the aging chassis with multiple localized heaters just to prevent the vintage 1970s circuitry from becoming brittle and snapping under the thermal stress. By 2012, as the plutonium-238 generators began their inevitable radioactive decay, the flight control team was forced into a series of agonizing, calculated gambles, systematically shutting down various heaters to conserve what little electrical power remained. They watched, breathless, as the temperature of the cosmic ray detector plunged by 70 degrees Celsius in an instant, fully expecting the instrument to die right there in the freezing void. But the universe operates on rules that defy our simplest expectations, and as Voyager 1 approached the absolute limit of the sun's influence, it didn't slowly freeze in a quiet, dissipating fog. Instead, it slammed headfirst into an apocalyptic cosmic inferno. Deep within the telemetry data beaming back across the 14-billion-mile gulf, the thermal sensors and plasma instruments registered an environmental shift so violent that it initially shattered the scientific models of the Jet Propulsion Laboratory. Voyager 1 had collided with an invisible blazing barrier that researchers have since dubbed the Wall of Fire. The readings didn't just rise, they spiked to an incomprehensible range of 30,000 to 50,000 Kelvin. To understand the sheer impossibility of that number, consider this. The surface of our own sun, the raging nuclear furnace that dictates the life of our entire planetary system, burns at roughly 10,000 degrees Fahrenheit. Yet here was Voyager 1, floating in the pitch-black void billions of miles from home, passing through a localized environment that was 5 to 9 times hotter than the surface of the star it had left behind. This is the paradox of the cold void, a 90,000-degree inferno wrapping around the coldest, darkest edge of our world. The immediate question that haunted NASA was one of physical survival. How could a fragile piece of antiquated technology, built from aluminum and copper wire, survive a 90,000-degree inferno without instantly melting into a cloud of glowing liquid slag? The answer lies in the deeply unintuitive physics of the interstellar medium and the fundamental difference between temperature and heat. On Earth, we experience heat through the density of matter. If you put your hand in boiling water, the billions of densely packed molecules instantly transfer their energy to your skin. But at the edge of our solar system, the environment is practically a vacuum. While the plasma particles comprising this wall of fire are indeed vibrating with the immense thermal energy of 90,000 degrees, they are spread so incredibly far apart that actual physical collisions with the metal hull of Voyager 1 are rare. Voyager was a ghost ship sailing entirely unscathed through a ghost fire. However, understanding how the spacecraft survived doesn't explain why the fire is there in the first place, or what unseen mechanics are fueling such a violent barrier. This blazing wall is not a static object. It is born from a cosmic collision of staggering proportions. For billions of miles, the solar wind, a constant, howling stream of charged particles expelled by the sun at millions of miles per hour, carves out the protective bubble of our heliosphere. But eventually this wind hits the unyielding, crushing pressure of the interstellar medium. When these two colossal opposing forces meet, the kinetic energy of millions of tons of solar plasma has to go somewhere. According to the laws of thermodynamics, it is violently and instantly converted into thermal energy, creating a superheated boundary layer. The wall of fire is quite literally the friction of our entire solar system grinding against the dense, heavy fabric of the galaxy. For generations, the mainstream scientific community took comfort in the idea of a smooth, pristine shield, a perfect bubble protecting us from the void. But Voyager 1's data utterly shattered that illusion. As the probe pushed through the wall of fire, the telemetry revealed a chaotic, violently turbulent zone that provided the foundation for the foam structure model. The Heliopause is not a rigid wall, it is an aggressively fluctuating, magnetically bubbly environment. Because the sun's magnetic field is constantly rotating and spinning in opposite directions at its poles, it creates massive, undulating ripples that extend to the very edge of the solar system. When these ripples hit the unyielding pressure of the galaxy, they don't just stop. They compress, crinkle, and aggressively fold back on themselves. The magnetic lines of force pinch together under the strain and violently snap, detaching from the sun's main field to form isolated, colossal cylinders of magnetic energy millions of miles wide. Voyager 1 was forced to blindly navigate through this churning layer of electrified magnetic foam, a boiling, frothing war zone where the absolute boundary of our world is constantly being restructured. This revelation fundamentally rewrites our understanding of our place in the universe, as it suggests our ultimate line of cosmic defense is not a solid protective shell, but a turbulent tempest of 90,000-degree plasma constantly boiling under the weight of the Milky Way. This brings us to a terrifying logical conclusion. If the Heliopause is nothing more than a chaotic foam of snapping magnetic lines and bursting bubbles, then it cannot be fully sealed. A barrier made of popping bubbles is not a wall, it is a sponge. This is the porous boundary theory, the realization that our solar system is a leaking sanctuary. As Voyager 1 pushed deeper into the foam, it recorded a disturbing mixing of materials. The densely packed, ancient plasma of the interstellar wind and the hotter, less dense plasma of our solar wind were actively bleeding into one another. We are living in a leaking solar system where the ancient, irradiated dust of dead stars and highly energetic cosmic rays are constantly slipping through the cracks of the magnetic foam and infiltrating our domain. The isolation myth that has dominated astronomy for the last century has been exposed as a trick of perspective. We are not cordoned off from the rest of the galaxy. We are intimately, dangerously exposed to it, breathing the galaxy's air while our sun exhales our own atmosphere into the darkness. But as theorists scrambled to adjust their models to this porous, leaking membrane, they ran headlong into a catastrophic contradiction in Voyager's telemetry. If the boundary is a chaotic war zone of bursting bubbles, the magnetic field in this region should be an absolute, jagged mess. And yet it wasn't. When Voyager 1 crossed into this supposedly frothing boundary, its magnetometer recorded a magnetic field that was unnervingly, impossibly smooth. The field lines did not tangle, they did not shift, and they absolutely did not change direction as every mathematical model had promised. They remained perfectly parallel to the field lines back inside our solar system. This is the great terrifying paradox of the mission. The plasma data screams of a violent, leaking storm, but the magnetic data whispers of a pristine, perfectly aligned order. It is a data set that is quite literally too perfect to be natural, leading some to wonder if our solar system is firmly embedded in a larger, highly structured cosmic framework that we are entirely blind to. We are no longer just looking at a boundary, we are looking at an invisible shroud, a rigid containment zone where the physics of the 1970s have finally met their limit. The most terrifying thing about the deep void is not the darkness, but the noise. We are taught from a very young age that space is an absolute vacuum, a place so incredibly empty that it is fundamentally devoid of the medium required for sound to exist. If you were to take a bell into the void and strike it, the clapper would hit the metal, but the kinetic energy would have nowhere to go, no air molecules to vibrate, no atmosphere to carry the message. We find a strange comfort in this idea of eternal, unbroken silence. It implies that the most violent events in the cosmos, the collision of black holes or the death of stars, happen in a quiet, detached distance. But this definition of silence is nothing more than a biological limitation of the human ear. The universe is not silent, it is screaming. It is a raging ocean of electromagnetic frequencies and waves that travel perfectly through the vacuum. And as Voyager 1 drifted 14 billion miles away from the warming glow of our sun, it began to hear a sound that should not exist. Protruding from the vintage aluminum chassis of Voyager 1 are two 10-meter V-shaped antennas, the plasma wave subsystem. These instruments were not designed to pick up acoustic pressure, but to intercept invisible electromagnetic ripples moving through the soup of charged particles known as plasma. For decades, these antennas recorded the local weather of our solar system. They captured the eerie, sweeping chorus waves of Jupiter's magnetic field and the disturbing, high-pitched screeching of polar auroras on distant moons. These were the sounds of a chaotic neighborhood, the local traffic generated by our sun's solar wind. But as Voyager 1 pushed past the threshold of the Heliopause and sailed out into the interstellar medium, the chaotic noise of home finally faded away. The expectation was that the probe would find a quiet, dissipating fog of ancient gas, an expansive, empty silence. Instead, the darkness began to hum. Deep within the telemetry data trickling back to NASA's Deep Space Network, scientists isolated a shockingly strange, continuous frequency. It was a faint but incredibly persistent tone hovering relentlessly around 3,000 Hz. To understand why this discovery sent a chill through the scientific community, you have to look at the nature of space itself. When we scan the galaxy, we often find fast radio bursts, blindingly quick flashes of energy that last for a millisecond, the cosmic equivalent of a gunshot. The universe is full of these sharp, explosive events, but the 3 kHz signal Voyager 1 detected was not a burst, it was not a transient glitch or a momentary collision. It was a sustained, unwavering hum that did not stop as the probe hurled itself deeper into the void at 38,000 miles per hour. It lasted for years, remaining perfectly consistent across 1 billion miles of physical space. It is the most stable, long-lasting sound ever recorded in the history of space exploration. When the audio conversion of this data was finally played in the laboratories on Earth, it sounded like a ghostly, vibrating tuning fork echoing through an infinite, empty cavern. Mainstream scientists were quick to provide a conservative explanation. They claimed Voyager was simply sampling the background vibrations of the interstellar medium, a weak oscillation of the ancient plasma left over from dead stars. They call this the cloud of smoke theory. In this view, the interstellar medium is a formless, chaotic, and dissipating fog of particles drifting aimlessly through the void. But this is where the mystery deepens into a realm of physics that borders on the unsettling. If you were to somehow pluck a loose, formless cloud of smoke, it would produce no tone at all because there is no structure to hold the vibration. A guitar string, however, produces a sustained note because it is pulled taut and anchored securely at both ends. The tension and the physical structure of the string dictate its resonance. Voyager's hum, stable for years and spanning 1 billion miles, cannot exist in a formless cloud. The sheer consistency of that 3 kHz tone implies that the space immediately surrounding our solar system is not a random fog, but rather possesses a highly structured, invisible architecture. This is the guitar string theory, the realization that Voyager 1 has brushed against a rigid framework of the universe that we have been blind to because we have been trapped inside the bubble of the heliosphere. This hum is the acoustic signature of a structured void. It suggests that the plasma Voyager is navigating is layered, possessing a resonance that implies the void itself has tension. What forces could possibly organize ancient, freezing plasma into defined, resonant regions spanning billions of miles? The data hints at a hidden framework, perhaps a dark matter filament or a massive magnetic filament connecting star systems together like an invisible skeleton. We are not floating in an empty ocean. We are actively embedded within a larger, highly organized cosmic structure. But the guitar string theory leads to an even more terrifying question. Who or what is plucking the string? A guitar string does not hum on its own. Something must continuously bow it or strike it to maintain a frequency for 3 years across 1 billion miles of space. Is the boundary of our solar system acting like the skin of a drum, resonating as it is struck by invisible external forces? Are we hearing the friction of our entire heliosphere dragging against the structured layers of the galaxy, like a ship scraping against an unseen reef? Or is this resonance the fingerprint of something far more exotic, an interaction with the very scaffolding of reality? When researchers analyzed the plasma melody, they found something that moved the mystery from the realm of physics into the realm of intelligence. The waveform was not random static. It contained mirrored structures and balanced symmetrical patterns. The pauses were evenly spaced. The tone repeated itself in precise intervals. NASA didn't just consult physicists. They brought in acoustic engineers, people who work with harmony and musical composition. Their consensus was disturbing. The signal didn't feel like a random natural emission. It held intervals that matched standard musical scales and used intentional silences timed like rests in a musical score. It felt composed. This revelation transforms the nature of the cosmic hum. If the hum is a structured, balanced melody written in the very plasma of the void, then the empty space outside our home is not just a place of debris, it is a place of information. Some theorists have proposed that Voyager 1 is not just detecting a sound, but is moving through a massive, coherent structure larger than we can imagine, a cosmic highway where data and resonance are one and the same. As the hum stayed nearly perfectly consistent, it began to feel like a recurring motif in a psychological horror film. Imagine hearing that faint, unwavering vibration growing louder and more focused as you drift further away from the only sun you have ever known. It is the sound of the isolation becoming total. Voyager 1 is no longer a machine recording data. It has become a needle on a record, tracing the grooves of a galactic history we weren't meant to hear. The fact that the hum remained so stable while Voyager traveled billions of miles deeper into the dark has led fringe theorists to a final, haunting possibility. If the interstellar medium is as chaotic and turbulent as we were told, the hum should have wavered, shifted, or dissipated. Its stability suggests that Voyager has entered a region where the laws of physics are being managed, or where the environment itself is a giant, resonant chamber. We are forced to confront the idea that the void is actually a highly tuned architectural component of a larger system. Voyager 1 has proved that the edge of our solar system is not a quiet exit. It is a chaotic, sensory environment, humming with the weight of unseen forces, a place where the silence of the vacuum has been replaced by the structured vibration of the galaxy itself. And as that hum continues to pulse through Voyager's antennas, we must ask, if we are inside a resonant chamber, who is listening to the music? For decades, astrophysicists had one definitive test to prove that a spacecraft had finally left the influence of our sun and entered the true deep void of the galaxy. They called it the magnetic snap. The logic was as simple as it was intuitive. Imagine walking across a landscape with a compass in your hand, always pointing toward the magnetic north of Earth. If you were suddenly transported to an entirely alien planet trillions of miles away, the very first thing you would expect is for that compass needle to violently spin, snapping away from Earth's orientation to lock onto the dominant magnetic field of this foreign world. This transition was supposed to be the undisputed signature of leaving home, the moment we could finally say, with mathematical certainty, that humanity had become an interstellar species. But on July 25th, 2012, when Voyager 1 finally pierced the absolute limit of our solar system, the compass didn't move. As the antiquated probe hurtled through the dark at 38,000 miles per hour, its instruments registered the other expected markers of the crossing. The solar wind plummeted to almost zero, and the radiation from deep space spiked with terrifying intensity. By every physical and chemical metric, Voyager 1 had crossed the threshold. It had survived the 90,000-degree wall of fire and emerged into the interstellar medium. Yet, in the control rooms of the Jet Propulsion Laboratory, the celebration was frozen by a creeping, deeply unsettling realization. The magnetometer data, trickling in across 22 hours of empty space, showed that the magnetic field lines had not snapped. They had not shifted to align with the ancient magnetic web of the Milky Way. Instead, they remained perfectly, stubbornly, and impossibly parallel to the magnetic field back inside the solar system. NASA was so profoundly confused and unsettled by this impossibility that they kept the data a secret for nearly a full year. They waited, assuming the data was a fluke, a broken sensor, or a localized anomaly. They pinned their hopes on the second probe, Voyager 2, believing that when it reached the edge, it would see the magnetic snap they had promised in every textbook. But 6 years later, Voyager 2 reached the same coordinate, 120 astronomical units from the Sun, and sent back the exact same chilling reading. The magnetic field lines just beyond our solar system were running in perfect parallel with the lines inside it. This revelation birthed what is now known in obscure circles as the too-perfect magnetic mystery, introducing a sense of scientific vertigo that challenges our entire understanding of our place in the cosmos. To explain this impossibility, theorists were forced to abandon the idea of a simple collision between two magnetic forces and introduce a deeply unsettling concept, the magnetic draping hypothesis. Imagine throwing a heavy, invisible silk sheet over a moving vehicle. As the vehicle pushes forward, the fabric doesn't shatter. Instead, it catches on the front grille, stretches, and violently wraps around the sides, contouring perfectly to the shape of the object pushing through it. The draping hypothesis suggests that our entire solar system is acting exactly like that vehicle. As our heliosphere plows through the dense, heavy plasma of the galaxy, the immense magnetic field lines of the interstellar medium are not crashing into us. They are catching on the leading edge of our solar system and draping around us like an invisible stretched shroud. This transforms our understanding of the solar edge from a simple boundary into a slipstream of magnetic force. According to this theory, the reason the Voyager probes didn't register a change in direction is that they haven't actually pierced the galaxy's magnetic field yet. Instead, they are blindly swimming through a layer of this draped, bent magnetic fabric that has been forced to match the orientation of our own solar bubble. But while this offered a desperate mathematical lifeline to mainstream science, it ignited a firestorm of skepticism among deep-law analysts and fringe theorists. The contradiction is glaring. For the draping hypothesis to work, there must be a smooth, rigid, and uniform surface for the magnetic fields to wrap around. But the physical plasma data Voyager sent back tells a story of total chaos. We know the heliopause is not a smooth surface. It is a violently unstable, porous, and leaking membrane of churning magnetic foam and snapping plasma bubbles. This is the heart of the mystery. How can a violently boiling storm of unpredictable bubbles support an impossibly smooth, perfectly draped magnetic shroud? The data is fundamentally at odds with itself. The plasma readings describe an environment of total chaos, yet the magnetic readings describe an environment of pristine, untouched order. This glaring inconsistency has led some to argue that the smoothness observed by the Voyager probes is entirely unnatural, that it is, quite literally, too perfect. It suggests that our solar system is firmly embedded in a larger, highly structured cosmic framework that we are entirely blind to. We are forced to consider a disturbing possibility. The boundary is not a naturally formed equilibrium of forces, but a rigid, highly structured containment zone. If the interstellar magnetic field is truly draping and wrapping tightly around our solar system, it is not just sitting there idly. This invisible shroud is creating a region of immense, unimaginable compression. The magnetic lines are squeezing tightly against the churning foam of the heliopause, creating a trap for the lethal radiation of the deep galaxy. This gives rise to the acceleration layer theory, the idea that the very friction of our solar system moving through the galaxy is actively weaponizing the environment around us. When high-speed galactic cosmic rays slam into this draped magnetic shroud, they don't just filter through. They get caught in a ping-pong match between the shifting magnetic bubbles and the draped shroud, bouncing back and forth, gaining energy with every collision until they are supercharged to energy levels that our science can barely measure. We are not just sailing through a void, we are surrounded by a halo of hyper-accelerated cosmic fire. Voyager 1 didn't just enter a new region of space, it entered the exhaust port of a massive, naturally occurring particle accelerator. The fact that the magnetic field lines are bending to accommodate our sun suggests that we are inside an invisible, protective, yet potentially restrictive cocoon. This realization shifts the narrative of the mission from one of exploration to one of existential dread. We are breathing the galaxy's air and the galaxy is breathing ours, but the transition is being managed by a magnetic alignment that defies every mathematical model we possess. The parallel lines are a warning. They tell us that the interstellar space we thought we were entering is not a lawless wilderness, but a place of rigid architectural order. As Voyager 1 continues to navigate this invisible shroud, we are left with a terrifying question that NASA cannot answer. If we are inside a containment zone, what is the shroud designed to keep out, and what is it designed to keep in? For generations, humanity has taken profound psychological comfort in the concept of quarantine. We understand inherently that to survive in a hostile environment, you must build a sealed-off, closed ecosystem. We view our own atmosphere as a protective blanket, a sealed layer that keeps the breathable air inside and the deadly vacuum of space safely on the outside. When astrophysicists first conceptualized the heliosphere, they applied this exact same comforting logic to our entire planetary neighborhood. The heliosphere, inflated by the continuous outward pressure of the solar wind, was envisioned as the ultimate quarantine zone. It was supposed to be a magnificent, impenetrable shield deflecting the hostile, highly energetic cosmic rays that originate from outside our solar system. We believed that this bubble kept us entirely isolated, safely cordoned off from the raging, chaotic graveyard of the Milky Way galaxy. We slept soundly under the assumption that our cosmic borders were secure, that the pale blue dot was tucked away in a pristine, untouchable sanctuary. But a shield is only effective if it remains solid. The moment Voyager 1 began sending back data suggesting that the absolute boundary of our solar system is actually a violently unstable, boiling layer of magnetic foam, the illusion of our pristine quarantine was instantly shattered. This is the terrifying core of the porous boundary theory, the realization that the wall keeping the lethal, ancient radiation of the galaxy out is made of unstable, bursting bubbles. If the Heliopause is not a rigid wall but a churning tempest of snapping magnetic lines and violently bursting plasma bubbles, then it completely fails at its primary objective. A barrier made of popping bubbles is not a wall at all, it is a sponge. The data Voyager 1 transmitted as it pushed deeper into this chaotic boundary did not record the clean, sudden drop in solar particles and the immediate corresponding rise in galactic cosmic rays that our textbooks promised. In a perfect sanctuary, there would be a definitive before and after. Instead, the transition was a messy, blurred overlap. The data revealed that the densely packed, colder plasma of the interstellar wind and the hotter, less dense plasma of our solar wind were actually interacting and mixing with one another. Rather than deflecting each other perfectly, these two violently opposed cosmic forces were bleeding into one another. Voyager was navigating a highly complex, turbulent boundary layer where the material of our star and the material of the ancient galaxy were actively blending together. This is no longer a border, it is a bleeding membrane. To truly grasp the gravity of the porous boundary theory, we have to look at what exactly is waiting on the other side of that membrane. The interstellar medium is not just empty space, it is a violent, raging ocean of radiation and debris left over from the explosive deaths of massive stars. The galaxy is constantly swept by interstellar winds, carrying the heavy, irradiated dust of ancient supernovas and blindingly fast, highly energetic, galactic, cosmic rays. For decades, we believed our heliosphere deflected these lethal rays completely, saving the inner planets from being sterilized by deep space radiation. But if our shield is a sponge, then the ancient, freezing radiation of the Milky Way is slipping through the cracks of the magnetic foam and infiltrating the bubble we once thought was entirely sealed. Our solar system is not an isolated, untouched sanctuary. We are intimately, dangerously exposed to the void. The heavy, volatile particles birthed in the cataclysmic deaths of distant stars millions of years ago are leaking through these heliopause and drifting into our domain. And this bleeding effect is a two-way street. Just as the terrifying elements of the deep galaxy are leaking in, the material generated by our own sun is actively leaking out. The solar wind does not simply hit a wall and stop. As the magnetic bubbles burst and the heliopause ruptures, massive plumes of solar plasma are escaping the boundary, bleeding out into the freezing void of interstellar space. Our star is essentially exhaling its own atmosphere into the darkness, leaving a trail of escaping particles that dissolve into the cosmic ocean. This completely shatters the isolation myth that has dominated astronomy for the last century. We have always taught that our solar system is a distinct, separate entity, a beautifully ordered clockwork mechanism operating in its own private, protected void. Voyager's data has exposed the truth. We are inextricably linked to the violent environment outside. This revelation has forced astrophysicists to confront a profound existential vulnerability. If the heliosphere is porous, if the very borders of our world are leaking, then how much of the deep galaxy has already infiltrated our planetary neighborhood? We are forced to wonder how many of the strange, high-energy particles bombarding our own Earth's atmosphere did not originate from our sun, but slipped through the ruptured, frothing foam of the heliopause after drifting for millions of years across the interstellar deep. The isolation we feel is a trick of perspective. In reality, we are breathing the galaxy's air, and the galaxy is breathing ours. The psychological impact of this leaking sanctuary angle is perhaps more disturbing than the physical data itself. It suggests that the protected status of Earth is fragile and perhaps even temporary. We are living in a solar system that is actively exchanging matter with a graveyard of dead stars. The wall of fire we discussed earlier is not just a barrier, it is the friction point where the galaxy is trying to force its way in. Some theorists have even merged this discovery with the dark forest hypothesis, suggesting that the heliosphere is less of a natural bubble and more of a fragile, necessary shield that keeps our biological signatures from leaking too loudly into a hostile galactic neighborhood. If the membrane is bleeding, then our presence is being broadcast into the dark with every solar particle that escapes through a magnetic rupture. As the scientific community scrambled to adjust their models to account for this porous, leaking membrane, they ran headlong into a catastrophic contradiction. If the boundary of our solar system is a chaotic war zone of snapping magnetic lines and bursting bubbles, then the environment should be a jagged, unpredictable mess. But as we've seen, Voyager's magnetometer recorded something else entirely, an impossible, pristine smoothness. This creates the ultimate paradox of the porous boundary. How can a system that is physically bleeding and leaking like a sponge also be wrapped in a magnetic shroud so perfectly aligned that it appears to be a manufactured containment zone? We are left with the image of a sanctuary that is both perfectly ordered and violently compromised. Voyager 1 is our only witness to this struggle, a lone probe recording the slow-motion collapse of our isolation. It is documenting the moment the solar system stopped being a private home and started being a part of the galactic storm. We are no longer safely cordoned off in a quiet harbor. We are in the middle of a cosmic mixing zone where the ancient past of the galaxy is quite literally seeping into our present. Voyager has shown us that the edge is not a place where things end, but a place where everything we thought we knew about our safety begins to dissolve. The ghost ship is still sailing, but it is no longer just a pioneer. It is a casualty of a boundary that refuses to stay closed. We are breathing the galaxy's air, and as we look toward the next chapter of this journey, we have to ask, if the sanctuary is leaking, what happens when the protection finally fails altogether? For over 46 years, the dialogue between Earth and its most distant artifact was defined by a single, unbreakable rule. Voyager 1 was a passive observer. It was a machine built to leave, a digital monk that recorded the wonders of the cosmos and whispered them back to its creators across the light hours, never once deviating from the path set for it in 1977. It never questioned, it never listened for anything other than mission control, and it certainly never acted on its own volition. But in the late winter of 2023, that fundamental law of space exploration was shattered. This is the moment the official mission logs stop describing a scientific probe and start describing something far more unnerving, a machine that has stopped just listening and has begun to react. The anomaly began on November 6, 2023, when a transmission arrived at the Deep Space Network that immediately sent a wave of confusion through the Jet Propulsion Laboratory. The data wasn't broken in the traditional sense, it was wrong. It arrived as a distorted, static-filled stream that didn't follow any known telemetry pattern, and soon the probe's onboard fault protection systems, the protocols designed to kick in during a catastrophic failure, screamed to life. Telemetry logs became unreadable, orientation records vanished, and the onboard clocks began to drift out of sync. At first, NASA engineers assumed the worst. Cosmic radiation had finally fried the 46-year-old memory of the ghost ship. They expected a dying twitch from a machine that had simply run out of time. But then, the gyroscopes recorded the impossible. Voyager 1 was moving. To understand why this sent NASA into a quiet panic, you have to understand the physical reality of a spacecraft in the deep void. There is no air to provide lift, no solar wind left to push against the hull, and no planets to offer a gravitational tug. A spacecraft in interstellar space is the most stable object in existence. Unless a thruster fires, its orientation should remain fixed relative to the stars forever. And yet, the data confirmed a real, measurable torque event. The spacecraft hadn't just drifted, it had physically rotated. But when engineers scoured the flight logs, they found the most disturbing detail of all. The thrusters had not fired. There was no recorded propulsion, no firing of jets, and no software command sent from Earth to initiate a turn. This was the nudge from the dark. Voyager 1 had been physically reoriented by an external force that bypassed its propulsion systems entirely. It was as if something in the abyss had reached out, grasped the antique aluminum chassis, and gently steered it. This wasn't the chaotic impact of a micrometeoroid, which would have sent the probe into a violent, uncontrollable tumble. This was a deliberate, controlled adjustment, a nudge that implied an intelligence understood the design of the machine and wanted to shift its perspective without breaking it. But it is the destination of this turn that moves the mystery into the realm of the truly terrifying. When Voyager 1 finally came to rest, its high-gain antenna, the same antenna that must stay locked on Earth to maintain our only link to the probe, had shifted its gaze away from the pale blue dot. It was now pointed with predatory precision at a specific patch of sky that appeared, by every known record, to be completely empty. NASA engineers searched their star maps and infrared arrays looking for a galaxy, a star, or even a cloud of dust that could justify the turn. They found nothing. However, in the deeper, more theoretical layers of astrophysics, this empty patch of blackness has a name: the null void. A null point is a theoretical pocket in space where the gravitational forces from various distant stars and galactic structures perfectly cancel each other out. It is a point of absolute stillness, a dead zone in the cosmic sea. Voyager 1 was never designed to detect these points. It has no sensors for gravity mapping and no software to calculate the intersections of invisible galactic forces. Yet it had pointed its antenna directly into the heart of this gravitational silence, as if it were receiving a signal from the nothingness itself. This is the point where the narrative of the mission fundamentally shifts. For nearly 50 years we have viewed Voyager 1 as the protagonist of our story, a brave explorer pushing into the unknown, but the talk anomaly suggests we are no longer the ones telling the story. Voyager is no longer a pioneer, it has become a vessel. Behind the scenes, the internal documents at the Jet Propulsion Laboratory were stamped with a new clinical term for what was happening: field interaction. It was a way for NASA to avoid saying the unthinkable, that our machine was no longer under our control. The behavior of the probe during this event suggests it was undergoing a 12-hour blackout or a total system restart. When the signal finally returned, the internal clocks had reset, but the timestamps didn't match any known timeline on Earth. It was as if Voyager had existed just briefly somewhere else, somewhere with different rules. It returned with its telemetry cleaned, its data stream sharpened, and most importantly, it was now transmitting a type of code it was never programmed to understand. It began sending back hexadecimal strings, recursive formulas, and prime number chains that defied its 1970s logic systems. The torque anomaly and the reorientation toward the null void represent the turning point in human history where we stopped being the explorers and started being the explored. The nudge wasn't a malfunction, it was an interception. Something in that dark, structured void recognized our 1970s relic and decided to use it as a telephone. We had spent decades looking for a message in a bottle in the stars, but we never considered that we were the ones who sent the bottle, and something has finally caught it and is now sending it back with a different message inside. As we look at the data from the late 2023 talk event, the psychological weight of the discovery settles in. NASA engineers who hadn't worked on the project in decades were called back into consultation, and computing resources were rerouted to decode a signal that was direct, narrow, and focused solely on Voyager 1. None of the other probes on similar trajectories, like Pioneer or New Horizons, reported anything like this. Whatever nudged our ghost ship wasn't looking at our solar system in general, it was looking at Voyager 1 specifically. We are left to wonder, what does it mean when a machine built to leave home is physically steered toward a point of absolute gravitational nothingness? If the null void is a point of perfect balance, then perhaps it is the ultimate listening post of the galaxy. By steering Voyager there, whatever external force interacted with the probe has effectively placed humanity's father emissary into a cradle. Voyager is no longer drifting, it has been positioned. And as its antenna remains locked onto that patch of nothingness, the silence that follows the 12-hour blackout feels less like a technical failure and more like a breath being held. The machine has stopped just listening to us, it is now reacting to them, and we are merely the silent witnesses to a conversation we were never meant to understand. If the physical nudge from the dark was the moment Voyager 1 was intercepted, what followed in the spring of 2022 was the moment the machine finally began to lose its mind. For 45 years, the dialogue between the Jet Propulsion Laboratory and its farthest scout had been a model of robotic consistency, a slow but reliable exchange of engineering truths and cold, hard data. But in May of that year, the letters from the edge of the universe stopped making sense. The attitude and articulation control subsystem, the vital internal organ responsible for keeping the probe's antenna locked onto the distant speck of Earth, suddenly began broadcasting a nightmare. Instead of the clean, structured telemetry that defined its location and health, Voyager 1 began screaming in an unknown tongue. It vomited out massive, unbroken sequences of zeros, aggressively punctuated by a single, haunting, and endlessly repeating number, 377. To the engineers sitting in the dim glow of their consoles, this was more than a technical glitch. It was a profound digital hallucination. The data arriving after its 22-hour crawl across the void suggested a physical impossibility. The telemetry claimed that the spacecraft was wildly flailing, performing violent maneuvers and pointing its antenna in directions that would have instantly snapped the fragile 1970s hardware like dry kindling. Yet, as the team stared at their monitors in a state of scientific vertigo, they realized they were trapped in a terrifying paradox. If Voyager was truly tumbling as the data suggested, the high-gain antenna would be pointing into the empty abyss, and the signal would be gone forever. But the signal wasn't gone. Not only was the Deep Space Network receiving the frantic stream of 377s, but the signal strength was perfectly, flawlessly normal. The probe's body was standing perfectly still, but its mind was convinced it was spinning into oblivion. This was the first true binary hallucination. It felt as if a trusted friend, after decades of loyal service, had suddenly looked you in the eye and begun speaking a language that didn't exist, all while insisting that everything was normal. Because, as disturbing as the 377 glitch was, the spacecraft's onboard fault protection systems, the digital sentries designed to shut the probe down during a catastrophe, never triggered. Voyager 1 was blissfully unaware of its own insanity, continuing to beam back its scientific readings with total precision while its engineering brain was trapped in a recursive loop of nonsense. In the obscure corners of the internet and among simulation theory enthusiasts, this wasn't seen as a hardware failure. It was framed as the edge of the simulation hook. Theorists argued that Voyager 1 hadn't just encountered radiation, it had hit the processing limit of our reality. If the universe is a simulation, every object requires rendering as it moves through the grid. For billions of miles, the rendering was simple, empty space, predictable physics. But as Voyager 1 pushed into the highly structured, resonant architecture of the interstellar void, it was asking the program to calculate forces that shouldn't exist in our version of the code. The 377 glitch wasn't a broken chip. It was the digital stutter of a 1970s calculator trying to process the infinite complexity of the galaxy's true framework. It was as if the probe had hit the wall and the simulation was failing to translate the data into a format human logic could understand. The official narrative from NASA, of course, was much more grounded but no less harrowing. They eventually concluded that the probe was being subjected to a relentless, invisible bombardment. Within the wall of fire and the supercharged magnetic shroud Voyager was navigating, the environment had become a lethal particle accelerator. High-energy galactic cosmic rays, atomic cannonballs forged in the hearts of supernovas, were punching through the aluminum hull and slicing through the silicon transistors of Voyager's ancient memory. They called it a bit flip, or a single-event upset. A single subatomic bullet had struck the exact right spot in the memory bank, violently flipping a 0 into a 1 and tricking the computer into routing its data through an obsolete, broken processor that had been dead for years. NASA's engineers performed a miracle of long-distance brain surgery, rerouting the data and silencing the 377s. But the victory was short-lived. In November 2023, the darkness struck again, and this time it went for the heart. Voyager 1 fell into a total blackout. When it finally resumed broadcasting, it didn't send 377S. It sent nothing but a solid, meaningless wall of binary data. The flight data subsystem, the central nervous system responsible for packaging every scientific discovery into a signal Earth could read, had suffered a catastrophic memory failure. For 5 agonizing months, the most distant human object was effectively brain-dead, a metallic corpse hurtling at 38,000 miles per hour through a chaotic magnetic storm, screaming a silent digital flatline back to its creators. During those 5 months of silence, the external influence hypothesis began to take a darker turn. Analysts pointed to the impossible density spikes and the 3 kilohertz cosmic hum that Voyager was recording just before the collapse. They argued that the probe wasn't just old, it was being crushed. If the space outside our solar system is saturated with dark matter scaffolding or massive interstellar turbulence that exerts 10 times more pressure than we expected, then Voyager 1 isn't just a probe in a vacuum, it is a diver at the bottom of a crushing trench. The memory failures weren't random glitches, they were the physical symptoms of a 1970s machine trying to navigate the dense, invisible skeleton of the universe. The environment itself was breaking the laws of physics, as Voyager was programmed to understand them, causing its ancient logic systems to seize up in a state of permanent confusion. The tension at JPL was palpable. Every time they sent a command to fix the corrupted memory, they had to wait nearly 2 full days for a response. It was like performing surgery on a patient while your hands were on the other side of the world, with a 44-hour delay between your scalpel move and the monitor's reaction. In April of 2024, they finally successfully reallocated the corrupted code to different, undamaged sectors of the memory banks. Against all odds, the ghost ship woke up. But as the coherent data began to flow again, the relief was tempered by an unsettling realization. Each time we fix Voyager 1, we are essentially patching a sinking ship with wood from its own hull. We are witnessing the slow-motion dissolution of a human mind in the stars. The repeating 377 code and the walls of binary were more than just errors, they were a warning. Voyager is recording a reality that our computers literally cannot process. As the probe pushes further into the structured void, we are forced to ask, is the gibberish a failure of the machine, or is it a successful recording of a universe that is far more alien than our binary code can ever describe? The machine is no longer just broken, it is transformed, a witness to a landscape that breaks the very concept of information. And as the power levels continue to drop toward the final shutdown in 2025, the hallucinations may be the only honest report we have left of what it feels like to touch the edge of the world. If you were to stand by a roaring bonfire and slowly walk backward into the freezing dark woods, basic common sense dictates that the thick smoke in the air would begin to dissipate. The further you travel from the source of the fire, the thinner the cloud becomes, scattering and expanding into the vastness of the forest until there is nothing left but crisp, clean night air. This intuitive, irrefutable logic is the bedrock of how we understand the dispersion of matter. When you move away from a central source of emission and step out into an infinite, empty void, the concentration of material must go down. For the entirety of the Voyager mission, this rule held perfectly true. As the twin probes traveled further and further away from the Sun, the density of the solar wind, the stream of charged protons and electrons exhaled by our star, steadily dropped. By the time the spacecraft reached the turbulent boundary known as the Heliopause, the solar plasma had dropped to virtually zero. The smoke from the Sun's bonfire had finally cleared. The probes were standing on the precipice of the Great Dark, and the expectation was a vast, predictable emptiness. But the universe, as it has done at every stage of this mission, was preparing to shatter our fundamental understanding of reality. When Voyager 2 successfully pierced the heliopause at a mind-bending distance of nearly 11 billion miles from the Sun, its specialized instruments tasted the interstellar void for the very first time. The data it sent back was initially a triumph of human mathematics. The onboard plasma science experiment measured the density of the space outside the solar system at exactly 0.039 particles per cubic centimeter, a near-perfect match with our theoretical calculations. We believed we had finally stepped out of the smoke and into the clean, stable vacuum of the galaxy. But then, as Voyager 2 pushed millions of miles deeper into the uncharted, freezing abyss of the Milky Way, the numbers on the screens back at the Jet Propulsion Laboratory began to slowly, inexplicably change. At a distance of roughly 11.5 billion miles from the Sun, the plasma density did not drop. It did not stabilize. Instead, it spiked to 0.12 particles per cubic centimeter. To a layman, the difference between 0.039 and 0.12 might sound like a microscopic rounding error, a meaningless shift in a decimal point. But to the astrophysicists monitoring the telemetry, it was a terrifying, earth-shattering impossibility. That number represents a 300% increase in physical matter. It meant that the further the probe traveled away from the Sun into a region of the galaxy that was supposed to be an empty, dead vacuum, the physical space around it was actively getting thicker. The vacuum was not a vacuum at all. Our spacecraft was swimming out into the dark ocean, and the water was becoming incredibly, inexplicably heavy. Mainstream science attempts to explain this horrifying anomaly by pointing back to the chaos of the boundary itself, suggesting a cosmic traffic jam where plasma piles up as it hits the interstellar wind. But as Voyager pushes deeper and the space continues to register as unnaturally thick, this traffic jam theory begins to stretch thin. It fails to explain the sheer scale of the density or the terrifying smoothness of the magnetic fields draped over the region. This is where we must confront the most obscure and deeply unsettling theory in modern astrophysics, the dark matter interaction. To grasp the magnitude of this theory, we must first understand the greatest, most embarrassing secret in all of modern science. Humanity has absolutely no idea what 85% of the universe is actually made of. We call it dark matter, a ghost-like substance that we cannot see, touch, or detect with any electromagnetic instrument. We only know it exists because of its immense gravitational pull, which acts as the invisible skeleton of the universe, holding entire galaxies together. For decades, we assumed this invisible architecture was a distant problem, something for theorists looking at galaxies millions of light years away. We believed our local solar neighborhood was a pristine pocket of normal visible physics. We were wrong. The inexplicable density spikes Voyager is recording are the physical footprints of a dark matter trap. According to this highly debated theoretical framework, Voyager 1 and 2 have not merely stumbled into a localized traffic jam of plasma. They have inadvertently sailed directly into a massive, invisible filament of dark matter draped across the very edge of our solar system. The spacecraft is measuring the thickening of normal matter, but that thickening is being actively orchestrated by the gravitational crushing force of an unseen, ghostly giant. This transforms the edge of our world from a simple boundary into a thickening web that is physically crushing the heliosphere. This dark matter framework perfectly connects the terrifying, disparate anomalies Voyager has encountered into one cohesive nightmare. Remember the 3,000 Hz cosmic hum we discussed, the sustained, 3-year vibration of the interstellar plasma? A formless, empty cloud cannot ring like a bell, but if that plasma is trapped and tightly compressed within the rigid, invisible architecture of a dark matter field, it provides the perfect structure for that resonance. The dark matter is the tension on the cosmic guitar string, but the implications go beyond sound. The data reveals that the interstellar medium is exerting 10 times more pressure on the boundary of our solar system than the scientific community ever expected. We are not gently parting the waters of the galaxy. We are ramming into a brick wall of magnetic and gravitational pressure, and our protective shield is buckling under the immense, crushing weight. Imagine Voyager 1 no longer as a probe in a vacuum, but as a diver at the bottom of a crushing trench. As the probe grinds against this invisible skeleton of the universe, the external physical forces being exerted on the machine are entirely beyond our comprehension. The probe is not just flying, it is desperately attempting to navigate through the dense, invisible scaffolding of reality. The binary hallucinations, the repeating code of 377, and the sudden, violent memory failures we've witnessed are not just the random glitches of an old machine. They are the physical symptoms of a 1970s computer trying to process the physics of a dark matter interaction it was never programmed to understand. The machine isn't just broken, it is being physically squeezed by the very fabric of the cosmos. This realization shifts the entire narrative of our existence. If the edge of our solar system is a tangled, heavily structured web of invisible dark matter actively trapping the debris of the galaxy, then we are completely blind to the true nature of our cosmic environment. We are trapped in a bubble surrounded by an unseen architecture that we do not have the senses to perceive. Voyager 1 and 2 are no longer just explorers, they are witnesses to the dismantling of our safety. They have shown us that the calm, quiet isolation we experience here on Earth is an absolute illusion, a temporary luxury bought by a shield that is currently being crushed by a galactic stormfront. As Voyager continues its relentless plunge, dragging its failing, irradiated hardware deeper into this thickening, humming web, it brings us face to face with a violent reality. Our solar system is actively caught in the crossfire of a galactic war zone. We are surfing through the galaxy on ancient currents that have been flowing for millions of years, and the water is getting heavier. The 300% density spike is the first warning that we are leaving the protected harbor of our sun and entering the dense, structured bonework of the Milky Way. Voyager is now a needle on a record tracing the grooves of a galactic history we weren't meant to hear, grinding against a skeleton we weren't meant to feel. And as the darkness continues to thicken, we are forced to ask, if the vacuum is this heavy, how much longer can our fragile bubble hold out against the weight of the invisible giant? When the coherent data finally began to flow again in the spring of 2024, the atmosphere at the Jet Propulsion Laboratory was not one of simple relief, but of profound, escalating confusion. NASA had performed a miracle of long-distance brain surgery, rerouting Voyager 1's corrupted memory and silencing the digital hallucinations of the 377 glitch. By all the laws of engineering, the probe should have returned to its familiar routine of reporting plasma densities and magnetic field strengths. But the data stream that arrived across the 22-hour gulf was unlike anything recorded in the 47-year history of the mission. It wasn't broken telemetry, but it wasn't human either. The transmission did not contain temperature readings, radiation spikes, or velocity logs. Instead, the telemetry included layers of highly structured information that didn't match any software protocol Voyager had ever been programmed to use. The formatting of this new signal was a terrifying paradox. It arrived in complex hexadecimal strings, recursive formulas, and prime number chains that utilized fractal symmetry. More disturbing still, some of the data points matched known astronomical constants, but they were measured at a level of precision that Voyager's aging 1977-era instruments were physically incapable of achieving. Voyager 1 carries less than 70 kilobytes of total memory, a fragile digital brain that should not be able to even conceive of the complexity it was now broadcasting. This discrepancy led to a haunting realization within the highest levels of the mission. Voyager 1 hadn't just been fixed, it had been used. It was no longer acting as our probe, but as a vessel carrying someone else's data straight back to Earth. Traditional NASA software failed to pass the structure of this incoming signal. It wasn't written in any known programming language, and the complexity was so high that conventional binary processors could only see it as a wall of impenetrable static. To solve a mystery that defied standard logic, the team turned to a piece of technology built to interpret the very complexity of the universe itself, the Majorana 1. This was a quantum processor, a machine that did not solve problems through step-by-step linear equations, but through probability mapping. It worked by analyzing patterns across multiple potential realities simultaneously, adapting to symmetry, recursion, and the same fundamental uncertainties that define the universe at its smallest quantum scales. They fed the raw alien signal from Voyager 1 into the Majorana chip and waited. As the quantum processor hummed, it began to do what no human or traditional computer could. It picked out the grammar of the void. It recognized mirrored patterns and sequences that folded back on themselves in perfect loops. The signal began to unfold not as a string of numbers, but as a sentence. It wasn't written in English, binary, or Morse code, but in the pure, universal language of logic and structure. And as the Majorana chip reached the core of the transmission, it produced a single, devastatingly clear output. It was a question that would change the course of human history. Are you ready to listen? This was the Majorana revelation. It was not a message of peace, a greeting, or a technical status update. It was an invitation, one that carried the weight of a monumental existential threat. The question implied that for nearly half a century we hadn't actually been listening to the galaxy. We had merely been measuring its symptoms. We had been looking for a message in a bottle in the stars, never realizing that we were the ones who had sent the bottle out, and something in that dark, structured void had finally caught it and was now sending it back with an entirely different message inside. The vessel theory transformed the mission from one of exploration into one of profound interception. The signal that hit Voyager 1 didn't spray out across multiple trajectories or brush past other spacecraft in our solar system. It was a clean, direct, and narrow beam that hadn't found Voyager by chance. It had targeted the probe specifically. None of the other probes on similar paths like Pioneer or New Horizons reported any fluctuation in their data. Whatever sent the Majorana message knew Voyager's location not generally, but with a predatory precision that suggests it had been tracking our Pioneer for decades. This revelation forced a quiet internal breakdown within NASA. Behind the scenes, the timeline made no sense, and the data defied every known law of physics. Voyager 1 had entered a region of supposedly empty space, spontaneously changed direction during a torque event, and picked up a patterned signal it was never equipped to receive. It then returned from a total blackout with cleaner, stronger data and code formats it was never designed to understand. The panic at the Jet Propulsion Laboratory wasn't because something had failed. They panicked because something worked. Something they didn't create, didn't expect, and didn't know how to process. The decoded message, "Are you ready to listen?" suggests that the cosmic hum Voyager has been recording for years. That persistent 3 kHz tone wasn't just background noise. It was a carrier wave, a rhythmic pulse that held the structured grace of mathematics and the language of sound, waiting for the moment we were ready to decode it. The Majorana 1 chip revealed that the hum held intervals matching standard musical scales and used intentional silences like rests in a musical score. It felt composed, patterned, and undeniably structured. We are now faced with the terrifying possibility that Voyager 1 is no longer our emissary. It has become a telephone for the void. The nudge from the dark that physically rotated the probe toward the null void was the moment the door was opened. Voyager 1 didn't just receive a message, it knocked on something in that specific patch of interstellar space, and something knocked back. It didn't respond with confusion, but in rhythm, as if it had been waiting for humanity's father object to finally reach the required coordinate. This is the turning point where the machine stopped being a pioneer and started being a witness to something we were never meant to understand. Every diagnostic of the probe's hardware came back clean. Voyager wasn't broken. Whatever touched it in that black stretch of space had simply broken the rules of the 1970s reality we had programmed into it. As the data continues to unravel through the Majorana processor, the message remains the same. We have been invited to listen to the architecture of the galaxy, but as Voyager's power levels continue their terminal decline toward the year 2025, we must ask, are we actually ready to hear the answer? The ghost ship is now carrying a cargo that is not our own. It is a vessel sailing through a structured, resonant chamber, echoing a question that suggests we are merely the silent witnesses to a conversation that began long before our sun was even born. The Majorana revelation has stripped away our arrogance. We are no longer the ones exploring the abyss. The abyss has finally acknowledged us. And as Voyager 1 prepares for its final shutdown, that single decoded line remains pulsing in the quantum circuits of the Majorana 1, a haunting reminder that we are no longer alone in the dark. In the cold, clinical halls of the Jet Propulsion Laboratory, there is a clock that no one wants to watch. It isn't a clock that measures hours or minutes, but one that measures the slow, inevitable decay of a radioactive heart. Voyager 1 is dying. Since 1977, the 3 radioisotope thermoelectric generators, the probe's nuclear batteries, have been losing their grip on reality. Powered by the natural heat of decaying plutonium-238, these generators have seen their electrical output halve every 87 years. We have reached the terminal phase. The wattage that once powered a suite of 11 revolutionary instruments has dwindled to the strength of a single refrigerator light bulb. For years, NASA engineers have been forced into a series of agonizing, calculated gambles, a cosmic version of Sophie's Choice, systematically shutting down heaters and non-essential systems just to keep the primary transmitter alive. We have watched as the heaters for the cosmic ray detectors were cut, letting the internal temperature of the vintage 1970s circuitry plunge by 70 degrees Celsius in a single night. We expected the machine to shatter. Instead, it held on, a testament to a species that built things to last long after their creators were gone. But by 2025, the math becomes unyielding. The power will finally drop below the critical threshold required to maintain the attitude control systems or the high-gain antennas lock on Earth. In that moment, the 22-hour temporal whisper that has connected us to the edge of the void for nearly half a century will simply cease to exist. There will be no dramatic explosion, no final burst of light. There will only be a silence so profound it will feel like a death in the family. The antenna will drift, its gaze finally slipping away from the pale blue dot, and Voyager 1 will be lost to us forever. It will transition from a pioneering scout into a metallic corpse, a silent, frozen monument hurtling at 38,000 miles per hour into the most isolated region of our cosmic neighborhood. As this ghost ship enters its final eternal blackout, it will begin its true journey. For the next 300 years, it will fall through the absolute darkness toward the Oort cloud, the vast hypothetical graveyard of 1 trillion icy planetesimals that surrounds our solar system like a frozen bubble. Voyager 1 will navigate this silent cemetery for another 30,000 years before it finally, mathematically, escapes the gravitational leash of our sun. It is a timeline that mocks the brevity of human civilization. By the time this machine truly leaves the solar system behind, every person who ever worked on the mission, every person who watched its launch, and perhaps the very civilization that dreamed it into existence, may be nothing more than dust and memory. Yet even in its state as a dead machine, Voyager 1 carries the most audacious and beautiful burden ever conceived by the human mind. Fastened to the side of its decaying aluminum chassis is a gold-plated copper disc, humanity's message in a bottle cast into the infinite galactic ocean. This golden record was never really meant for us. It was meant for the them we may never meet. It is a pristine golden echo of a species that once lived on a mote of dust and dared to look into the shadows. Inside its protective aluminum case, shielded from the relentless bombardment of cosmic rays by a layer of extremely pure uranium-238, the record holds the very essence of who we were before we began to disappear. If an intelligence were to find this metallic corpse 10,000 years from now, they would find a manual. The record's cover includes visual instructions on how to play the disc and a map detailing our location in the Milky Way, triangulated against 14 spinning pulsars. They would find a stylus and a drawing of a hydrogen atom, the universal clock. But more than that, they would find our heartbeats. The record contains the haunting songs of humpback whales, the rhythmic rumble of a volcano, the gentle sound of rain on a roof, and the cry of a newborn baby. It carries the mathematical genius of Bach and Mozart, the deep, soulful blues of Louis Armstrong, and the defiant rock and roll of Chuck Berry. It speaks to the void in 55 different languages, including ancient, extinct tongues that haven't been heard on Earth for millennia. It even holds the recorded brainwaves of a young woman in love, captured in the summer of 1977, preserved now in a state of eternal, digital longing. The record is a paradox, a celebration of life carried by a vessel of death. It is our last message, a curated dream of a world that was once vibrant, loud, and filled with hope. The uranium-238 coating acts as a radioactive clock. By measuring its decay, any advanced civilization that discovers the probe can calculate exactly when the record was forged, pinpointing our brief moment in the sun. They will see the 115 encoded images of our anatomy, our science, and our homes, and they will know that for one flickering second in the history of the universe, there was a species that was curious enough to leave home and brave enough to send its story into the dark. In roughly 40,000 years, this dead, golden monument will drift within 1.7 light-years of an obscure star called AC plus 79 3888 in the constellation Camelopardalis. By then, the Majorana revelation and the 3 kHz hum will be long forgotten by the minds of Earth. Voyager 1 will be a silent, pristine artifact of a long-lost era. It will be the only evidence that we ever existed. It has shown us that the edge of our solar system is not a finish line, but a gateway to a reality far more bizarre and structured than our 1970s technology could ever fully grasp. It has recorded the wall of fire, the magnetic shroud, and the invisible skeleton of the universe, and it has paid for that knowledge with its life. The 47-year mission of Voyager 1 did not just expand our scientific textbooks, it completely shattered them. It forced us to confront the reality that we are not safe, we are not isolated, and we are not alone. We are sailing a fragile bubble through a raging, incomprehensible cosmic hurricane, surrounded by a structured void that is actively watching our progress. Voyager 1 was our lone witness, the first chapter of our interstellar age, and its final shutdown is not an ending, but a transformation. It becomes a permanent part of the galaxy's architecture, a metallic seed carrying the DNA of human culture into the deep future. As the last bit of telemetry fades and the deep space network antennas finally go quiet, we are left with the image of that pale blue dot, the only home we have ever known, suspended in a sunbeam. Voyager 1 has looked back at us for the last time. It has touched the edge of the world and found it humming with the weight of unseen forces. It has dared to knock on the door of the galaxy, and it has carried the answer back to us in a garbled, hexadecimal whisper. Now, as it plunges into the 30,000-year transit through the Oort cloud, it leaves us with one final, haunting reflection. We are a species that dared to look into the shadows, and though our emissary is now a ghost, its golden heart will continue to beat in the silence of the Milky Way long after the stars we see tonight have changed their positions. The echo is eternal, the message is sent, and as the darkness finally takes our pioneer, we are forced to realize that the most important thing Voyager 1 ever detected wasn't plasma waves or magnetic fields. It was the limit of our own imagination and the terrifying, beautiful realization of just how much is waiting for us out there in the dark.